Hey, it's Becky. Welcome to the new Teardown series on my channel, where I'll take apart gadgets and share what I find inside. First up is the Pavlok, a shocking wearable designed to help you break bad habits. Give this video a thumbs up if you're excited to see this series come back to life. The Pavlok comes with the main device itself, as well as two silicone wristbands. The Pavlok pairs over Bluetooth with your phone to control the settings through an app, which is also designed to keep you motivated to use the device in the most effective way possible, because there is a method. You can deliver an electric shock to yourself via the app or by pressing the top of the device. It can also supposedly detect when you move your hand to your mouth, say during smoking or nail biting, which are two of the habits it's designed to help break. There it is. Okay, Pavlok widget. Ooh, it's a big widget. Okay. It has a plus and a minus for 50%. I think that's vibration. Ow! I think it did it at 50%. Okay, so I really don't want to, but I feel like I have an obligation to crank it up as high as I can tolerate for the sake of the lulz. So 20 is what I had been doing, which is unpleasant enough as it is. Let's try 30, 40. Ow! I felt like it moves my finger a little bit at 40. 50. Yeah, really, I can see it contracting one of the muscles in my hand. How can that be good? Okay, 60. Did you see it moving my hand? Ready? 70. It's not that bad, I guess, now that I'm getting used to it over and over in a row. 80%. Ow. Do you see it moving my hand?
A little.
Yeah, 90%. Stings. Okay, 100%. Ow! Okay, never again. Thank you. I think this is a great concept, and it seems to work great for those who stick to it. But this isn't a review, and I only tried out the different shock settings to see what they were like. I didn't like the feeling one bit, which I think is 100% the point. But if I were trying to quit smoking or nail biting, I think I'd be more interested in trying it for real because it can sort of act on your behalf. I couldn't bring myself to use it for snacking or teeth grinding, two of the habits I personally would like to stop, because I'd have to shock myself every time and also notice with regards to the teeth grinding. Personally, I am more into positive reinforcement than negative, but who knows? Maybe in the future, all smartwatches will come with this feature, zapping you when you're late on your bills or something.
Magnavolt, the final word in auto security. No embarrassing alarm noise, no need to trouble the police. And it won't even run down your battery.
Magnavolt. Lethal response.
Anyway, let's take it apart. I started cutting the plastic around the little metal nubs. The tricky thing about taking this thing apart, at least before the batteries died, is that it's easy to shock yourself while holding it in place. It's so small, one of the only flat surfaces by which to grip it is also the activation button. So I had to use the phone to make sure it was on a low setting and try to avoid pinching it while cracking open the plastic. After mangling the plastic near the nubs, one of the metal pieces came right out, exposing the circuit board inside. This enclosure design is pretty neat. The electrodes are also the case, which makes for a straightforward three-piece design. I was also able to put this one back together again, which is a rare occurrence in one of my teardowns. There's some interesting hardware crammed onto this board, so let's talk to my friend David, an electrical engineer, about the design of the circuit.
Hey, Becky.
Hi.
Brought this.
Thank you. Okay, so David and I already looked at the board. We took some really high resolution photos in order to be able to read all of the chips, and we looked up some data sheets. So we already know a little bit about what's going on. We have his microscope and my phone hooked up so that you can see what we're looking at on the screen at the same time.
Follow along at home.
Yeah.
You can see right here this QFN package labeled N52832. That is a Nordic semiconductor N52 series, which is a really awesome system on a chip, actually. It's got a Cortex M4 with an integrated floating point unit, which, if you think about where things were just a couple of years ago, that's an insane amount of power to have in a package that costs just a couple dollars. Also, this also does the control of the wireless radio and the Bluetooth system. So that makes these chips really, really popular for a lot of IoT devices you see these days.
Because most things are just Bluetooth radio with a microcontroller and sensor anyway.
Yeah, exactly.
Yeah.
And this is pretty similar, although it has some special stuff for the high voltage section.
Yeah, we'll get to that soon.
But yeah, it's pretty cool because you can see the chip is here, and then you've got the programming connector here. Whoever designed this has good taste, because I like this. This is called a Tag Connect programming header. Some of you out there who are familiar with Arduinos might be familiar with that 6-pin header.
The ISP.
The ISP header. But what's nice about this one is that you don't actually have to solder on a connector for it. You can buy this little cable called a Tag Connect that has pogo pins. And so when you're doing your manufacturing, you don't have to put that same connector on every time. You just plug it straight on. And then also close to the microcontroller, we have this. This is actually a chip antenna.
I've never seen one of these, or if I have, I haven't known what it is when I've seen it.
Yeah, because it's just a small surface mount package, but this actually is a fairly sophisticated component that wraps up something you might see printed in a much larger form factor on a circuit board. And the way you can tell what these are, I just know what these are because I've worked with them before. I recognize the little marking for this pin here. But you can see there's a cutout in the ground plane of the circuit board around the antenna to allow it to shape the electromagnetic field properly so it can have good communication with your phone.
Oh, that makes sense. Cool. Well, that's such a small area compared to like that little squiggle antenna you see on like the ESP8266 or something.
Yeah,
like that.
advanced electromagnetics are freaking crazy things.
That's cool. And it's in the middle of the board, right? Which is over the plastic part of the enclosure, not the metal part of the
no,
enclosure.
it's on the edge of the board.
It's on the edge of the board, but it's on the edge of the board in the middle where it's covered by the plastic part of the enclosure, not the metal part of the enclosure.
Yeah, they probably spent a lot of time getting this right because when you're developing a new device which needs to communicate wirelessly, every single thing from the position of the battery to where the ground plane on the circuit board is to what's going on with the enclosure to how people are going to even wear it on their body has something to do with how those electromagnetic fields can get out. So this looks really simple, but it actually probably represents a whole lot of somebody's really, really hard work.
Yeah. Good job, RF engineer.
Good job, RF engineers.
Let's talk about the sensors that we found.
Oh yeah, so we found two sensors. I'm not sure why, but it looks like they're actually using separate chips.
I know that little one is the accelerometer.
This guy right here, we looked it up. It's an accelerometer. This is actually a gyro. They're both by Freescale. You can tell from the 263 manufacturer's code.
Not all manufacturer. We were trying to find other chips by manufacturer codes, and like Freescale publishes, they say this is our manufacturer code, which makes it really easy to identify their chips. But not everybody does that. So
yeah, thanks Freescale.
But what could you speculate about why they're two different chips? I mean, they're both from Freescale, which means that if you're buying in bulk from them, you have a deal going on. But they do make integrated gyro accelerometers.
You can often find IMUs which integrate both the functionality of the accelerometer and the gyroscope. And so this design has them as separate packages. Feel free to shout out in the comments below as to why you think this might be. I mean, maybe they were just prototyping with two separate systems and it was easier to develop for that way. Maybe the prices at volume turned out that it was actually cheaper to get these.
They might have already had them around. Yeah, because the newer chips, the newer integrated ones maybe are slightly more expensive or harder to come by. Maybe Freescale had a bunch of these.
Yeah,
and
it could be like more complicated to manufacture the MEMS that are inside of it.
I mean, the space is obviously at a premium on this circuit board, but that accelerometer is not super huge. So if they did have the real estate, then it doesn't really matter, does it?
Put it down there.
Yeah.
And then let's see. Here we've got the the button that actually makes it work.
You can press the button with your
these little tiny little dudes there. This is a speaker. You can see it has a little hole to allow the sound waves to come out there.
It does make a beep when it can anyway make a beep.
These chips down here we weren't able to identify, but you can see they're very close. I'll flip this over. You can see they're very close to the USB plug. And you can see the battery goes directly into this capacitor here. So I believe that this section down here is probably the power conditioning and battery charging circuitry. Mm-hmm. And then this part right here is also interesting. This is what generates the high voltage. You can see that the components on this part are much, much larger than the rest of the board.
Right, like those are capacitors, but they're like the biggest surface mount capacitors I've ever seen.
Yeah, they're real big. And also they have this, there's this nice big fancy Coilcraft inductor on the back side.
Is that a brand name?
That is a brand name.
As a company that makes inductors?
They make really good inductors. They're called Coilcraft. Please give me free inductors. But I'm guessing that it's some kind of LC resonator, which will ring up between this inductor and these capacitors to generate the high voltage, which zaps you.
Adjustably zaps.
Adjustably zaps.
We have it on a really low setting right now.
Adjustable zapping. Yes, yeah. It's very important. It's of the future. And then, you know, these over here, this is what actually couples into the enclosure that you wear around your wrist.
So it like presses outwards against the metal, right? That part, that little clip, like presses, and then spring. I don't see anything that sticks out of the metal, so it's gotta like extend right to the edge of the circuit board, right? Yeah, it's kind of like off the end.
I'll turn it sideways here. It's kind of like springy a little bit.
Yeah. Oh, cool.
So you press it on there. And...
So that's neat. It's not glued to the enclosure. It just, it shouldn't be glued anyway to be conductive.
Yep.
Neat. What's on the other? So we got the button and the LEDs.
Side, well, it's mostly empty because we need to have this battery here.
But there's like there's a little vibration motor. I was surprised to see that it was such a big one instead of like instead of a little flat can. I was surprised to see the long kind.
Yeah, and these work for those of you who haven't seen these before. These are also fun. It has this like asymmetric weight on the end of it, so when it spins,
eccentric mass.
Yeah, the eccentric mass.
Yeah,
I've been called worse. But it generates the buzz that you can feel.
Yeah,
they're so tiny. Look at how small it is. That's my finger.
So the only things on the back of the board are where the battery connects, the USB port, the inductor. Yeah. I'll show the photo of the whole back of the board too. Yeah. That's kind of it, right? Vibrating motor, USB, inductor, battery. There's nothing else on the back of the board.
There's some
test points or something?
Test points, I think. On some little, I don't know what those guys are, but...
Oh, there are some components back here. Those are like little resistors or something, right?
Yeah, they could be.
Didn't you think this could be a 4-layer board? What would let you know?
I am guessing that this is a 4-layer board because you can see, well, first of all, look, everything is packed really, really, really close together. And so
you mean that the traces then have to have room to be underground because the components are so tight that that's something we generally do?
And you can also, if you look around, you can also see that there are some vias that don't seem to have any wires going to them.
Okay, well, is that all we can learn with the microscope?
I think so for now. I wish I knew what some of these other components were.
I know we looked for a long time for those little guys, and we couldn't find anything on the one that's on screen right now.
Yeah, I think this one's really interesting because it has its own
clock,
crystal resonator. Yeah, its own clock off to the side, which is like, why is it that? Is it another microcontroller or something? I don't know.
Can you read the letters off? We'll have our readers help us out.
Yeah. 063A0131830. So I mean, usually one of these is a manufacturer's code, and one of them is a date code, and one of them is a part number. But we did a lot of searching and didn't see anything about it. Yeah. But anyway, all right. Well, let's look at it some more.
Okay, let's switch to this oscilloscope.
Yeah, so I've got this probe hooked into channel 2 because I know this could be high voltage. I don't think it's going to break the input to my scope, but if it does, I'd rather it break channel 2 than channel 1.
Pro tip: when you're doing risky things, don't use
channel 1.
Your channel 1. Don't use your.
Okay, so I made some even smaller probe wires that attach to the probe here, and setting up the scope. So I'm gonna probe the capacitors here. Okay, so this is gonna be like 10% on the caps.
Ready? Boom.
Swoop. And so you can see that little dude there. That's 50 volts per diff. Let's grab one more of those. Yeah, that's interesting. So you can see it ringing up there. See, it's like starting slow and then. Yeah, but you can kind of see the waves there. And we can measure.
So how many volts is
let's look
that
at
one?
that pulse. So let's measure. Let's go peak to peak. Channel 2. Actually, no, sorry. I want cursors. Cursor 1 goes there. So at its maximum point, that's like a 65 volt back and forth. Let's turn up this, maybe turn it up to like 50%.
Okay. So that was 10%. Now I'm at 50%. Let me know when you're ready.
Okay.
Ready?
Okay, do it.
Woo.
Yeah, you see that one's a lot bigger.
That looks taller. So does that mean it's higher voltage? But we're not measuring the probes right now. We're just measuring the capacitors, right?
Yes, but the capacitors and the inductors work together to generate the energy that's going to go out. So now if I go back to my cursors, let's look at that. So that's at 50% now, and you can see that's like a 258 volt signal, peak to peak. It might be higher than that because it's looking like it might be clipping a little bit at the bottoms and on the sides. But
and your scope has a max 300 volts.
My scope has a max 300 volts. I don't have a high voltage probe that works with this scope. And there might be a couple of other things going on, but you can get an idea of what the signal looks like and how it changes between.
That's cool. And so why does it taper off like that at the end?
Because it has to ring down again. Let's probe the
actual shocking points?
Yeah, let's probe the shocking points.
All right, are you ready? I'm gonna crank it back down to 30 just because I don't want to hurt you.
Yeah.
Ready?
Ready. Okay, so you see here, it's interesting because it's not an AC signal anymore. It's just jumping up there to 100. Again. Oh, it's really long. Okay. Cool. 25 milliseconds per tiv. Alright, go. Yeah. I bet those are not continuous with each other. It could be like ringing up in one capacitor and then charging up the other capacitor. So like so this is ground here, and then when I measure here on this capacitor, it shows this like AC ring up situation.
Mm-hmm.
But when I probe ground here and probe this capacitor here, it just charges and then it discharges. So if I actually make that really small, and it charges and discharges here. So that is definitely a hint. Yeah, really nicely integrated.
Nice to see. Cool, thank you, David.
Yes, thanks, Becky.
Let's do the outro. So, what gadget should I take apart next? Let me know in the comments. Thank you so much for watching. Thank you, David, for helping. If you liked this video, please give it a thumbs up and subscribe with the bell to be notified of my future uploads.
Smash that like button.
Hi everybody, it's Becky, and it's time for a gadget review. The Garmin Fenix 6S Pro smartwatch is the first watch I've worn since the Moto 360. It's hailed as the ultimate sports and adventure watch and includes maps and onboard music storage. I was skeptical about wearing a watch at all, but wanted the fitness tracking features of an activity tracker in an attractive package I could wear anywhere. Timing is one factor that led me to Garmin though, since the Fenix 6S made one minor change over the Fenix 5 series that makes a big difference to me, the lug-to-lug distance. Previous 42mm Garmin watches were a little longer from lug to lug, so even though the screen's the same size, the Fenix 6S fits a smaller wrist like mine. I like how easy it is to change to different bands, especially because I can't stand the sticky feeling of the included silicone one. I picked up two different replacement bands, one a pink leather band and another heather black nylon band. It's super convenient to be able to check the weather from my wrist, and I'll admit I'm checking the date frequently as well. Depending on the watch face, you can see the time, date, and day of the week, altitude, barometric pressure, heart rate, battery life, weather, steps counter, floors climbed, notification counter, and a bunch of other data about your activity throughout the day. The Garmin Fenix 6S has special tracking features for almost any type of workout you can imagine. I use this feature for long walks or bike rides, and at the end I'll get a map of my journey as well as stats about the workout. I did try the yoga tracker once or twice, but it seems to want you to press a button for every pose, which seems fiddly to me and definitely does not work with my yoga flow. Since this is the Pro model, it also has maps, Wi-Fi, and can store music on board in case you want to go exercising without your phone. I enabled the always-on heart rate monitor on my Garmin to track my heart rate all day and all night. It helps to rationalize the physical sensation of a racing heart and also reminds me to get more exercise. But since my wrists are super small, I can see the red light of the heart rate monitor flashing from beneath the watch face, which is sometimes distracting while I'm trying to sleep. Notifications on Garmin have one big downside, and that is a pet peeve of mine. Each app's notifications are on by default and have to be turned off one by one. That means when I download a new app, I have to be sure to go into my Garmin settings and disable that app's notification, or my wrist will be buzzing with push alerts from non-essential places. This is part of a broader epidemic of notifications, but it's a particularly egregious example if you ask me. I use the Find My Phone feature super often. You can click a button on the watch, and if your phone is connected, it will start to ring and flash its flashlight. As a frequent phone misplacer myself, I love how much time this saves me. Part of setup was to configure the contactless payment methods. You need to enter a PIN once per day to use them, which is thankfully pretty secure, but mildly inconvenient at the checkout if you haven't thought ahead. One cool thing about contactless payment is that it's linked to your bank or credit account, not the card itself in most cases. So if I lose my wallet, I can still use my watch to pay for things while I get a new card in the mail. This is great peace of mind, especially for traveling. It took about 20 minutes to set up the main features of the watch, including pairing the Bluetooth, setting up the Wi-Fi, entering my biometric profile, contactless payment options, syncing my Strava account, and configuring the menstrual cycle app. I'm not thrilled with the limited default options available for the watch face, and the attractive ones available to download made by others tend to omit the data fields that I find so useful. I've settled on the in-focal watch face, showing time, steps, heart rate, date, altitude, current temperature, and battery life. I did shell out the extra cash for the sapphire glass version to protect against scratches much better than the Gorilla Glass version. I sleep near a brick wall, so I'm extra likely to scuff my watch against the brick on my way to the bathroom in the middle of the night, or, like using power tools in my shop. So far, so good. No scratches so far. This review is far from comprehensive, so I've put links to more comprehensive reviews that I like in the description below. Thank you so much for watching. If you like this video, please give it a thumbs up and subscribe with the bell to be notified of my future uploads. See you next time.
Hey everybody, it's Becky, and I just got my ham radio license. I started studying for my ham radio test at the suggestion of my friend David, who was also studying for his first license at the time. He made a strong pitch to my technological curiosity and urban survivalist interests by suggesting that we could potentially communicate with each other over ham radio without the assistance of the cell tower networks or the power grid at all. So I bought the spiral-bound technician class manual and its corresponding question book and began studying. Since I'm already familiar with basic electronics, some of the concepts were easy to grasp. Other topics were completely new to me, like ham etiquette and the regulatory stuff, and wave behavior stood out as particularly fun and novel. And I found an awesome AT&T vintage video about wave behaviors that really helped illuminate the subject beautifully for me. So I'll add a link so you can watch it too.
I'll clamp this last cross arm to a heavy stand so that a wave arriving here can't produce any displacement of the cross arm. This time you see the wave is reflected upside down.
I picked up a portable radio that I'd seen commonly recommended as a good first radio. It's a Baofeng UV5R, third generation, so I think it's an 8-watt radio. I looked up the times and the frequencies of the local ham nets in my area, and tuned my radio to listen in. I did find it especially helpful to pick up a programming cable too, so I could program my local repeaters and stations into my radio's memory. Listening to traffic nets made for a great backdrop for study sessions with David, my boyfriend Smokey. Folks check in from all over the NYC area and New Jersey, so there's an amusing variety among the accents that can be heard on the air.
And then give you call tonight. If you hold traffic, please list its destination. If you are willing to claim traffic or have any announcements, comments, or queries, please inform the control when you check in. This is November 2 Romeo Foxtrot, India, and to Waterfly, Lower East Side of Manhattan.
And then, I talked about my studies on Twitter and Instagram, and I found an outpouring of friendly support, call signs, and 73s. One really important thing I learned about filing for a license, the address you use to apply will be published in the FCC database, so use a P.O. box if you don't want to make your home address public. I took the exam in Brooklyn, and it happened in a conference room of a hospital admin building. 5 proctors led the exams, and I sat next to a preteen boy taking a more advanced level test than me. And I paid a $15 fee in cash, and the proctor checked my ID, and checked my calculator, because, no smartphones are allowed. And the certificate form was carbon copy. I filled out another form and also the info box on my answer sheet. It was very much like taking a standardized test. I had prepared by taking some practice tests online, all of which I passed, and fairly quickly. For some of the harder questions, though, it really helped to study the material, but also to practice the specific questions that tripped me up. During the exam, the proctors began to chat with one another, and most of them were whispering, except for one extra loud guy. Seems to be always the case. It was totally distracting, but I passed anyway. And so if you pass, you receive the opportunity to take the next level exam right away at no additional cost. And so even though I didn't study, I took the general exam. I didn't pass, but I didn't pay any extra either. But now I've got the general class manual, and I am studying for the next level exam, which will unlock some HF bands, some further away communication. So far, from my house with my little radio, I can only communicate with my closest repeater if I go outside or on the roof. So I'm already making plans to put up an antenna up there and run some cable inside, so I can make better use of my ham license in less than ideal weather. So if you're already a ham, please let me know your call sign in the comments below. I'm KD2SSU. And if you're interested in getting started in ham radio, I've put all the links to the products I mentioned in the description. Thank you so much for watching. If you liked this video, please give it a thumbs up and subscribe with the bell to be notified of my future uploads, all about technology, crafts, and my life here in New York City. See you next time. Hi everybody, it's Becky here with a maker tool review for you. Every maker needs a reliable utility blade, and my favorite, my old faithful, is the Olfa 5003 ratchet lock heavy duty utility knife. It's the most versatile option in a standard class of knives that includes those cheapo box cutters and those more industrial utility knives. Its biggest upside is the shaped metal blade holder at the tip, which keeps the blade from wobbling back and forth. When the ratchet mechanism is clamped in place, there's no play in the blade whatsoever. This Olfa knife takes standard box cutter blades, which you can snap off to refresh when the tip gets dull. To safely dispose of the used blades, though, wrap them in masking tape first so they don't make a hazard in the garbage. I love this knife. I've owned it for 17 years. I got it first freshman year in art school as part of my standard issue tools pack and quickly learned its indispensable value for almost every project. Need to cut some paper? How about score some foam core board or scrape some plaster or sharpen a pencil? The bright yellow Olfa knife was always there for me. And sure, it sliced a fair percentage of my classmates' fingers too, often incurred on late night work sessions, but that didn't happen to me yet, or with this knife anyway. And just because you might find this knife in the craft department doesn't mean it can't hold up on some heavier duty jobs like drywall and electrical. This knife's versatility is one of its best assets, and it's made in Japan from steel, ABS plastic, and a bit of brass inside the ratchet mechanism. Since college, I've used this knife to take apart tons of gadgets and build dozens and dozens of projects. It might be a little scuffed and a little dirty, but when it gets a fresh blade, it works just like new, even after a decade and a half of consistent use. I really admire any company that makes long-lasting tools, because it's a business model on the decline, giving way to disposable culture that's ruining the planet. I do try to say thanks by purchasing genuine Olfa brand blades and speaking highly of their tools whenever I get the chance. The other thing I like about this knife is the sound it makes. I know that sounds silly, but listen. To me, I've used this knife so much while learning and making new things that sound really reminds me of getting things started and getting things done. In case you're interested in picking up one of these Olfa knives, I put a link in the description. Thanks so much for watching. Don't forget to subscribe to my YouTube channel and my email newsletter, and leave a like and a comment down below. See you next time.
Hey, it's Becky. Here is how to sew a fabric face mask suitable for personal use or donation. This pattern is by Jessica Nandino in her Instructable called AB Mask for a Nurse by a Nurse, which I'll link in the description. Here in New York City, we're being advised to cover our faces when we go outside, but not to take away commercial surgical masks from healthcare workers who need them the most. That's where this homemade mask comes in. It's not a sufficient replacement for real respiratory protection, but it's better than nothing. I made a few of these for my family and neighbors, and many others globally are sewing as many as they can to donate to their communities. I put a link in the description about ways you can get your donations to hospitals in New York City, which can use the fabric masks over top of their surgical masks to extend their life. To make the mask, use 100% cotton fabric and thread with a tight weave, such as quilting fabric. 100% cotton is important because it can stand up to the high heat during cleaning, including potentially in an autoclave. When making masks for others, be sure to sanitize your workstation, tools, and wash your hands before you begin. Consider wearing a mask yourself while making. Print or draw out your pattern and use it to cut 2 of the pattern pieces from along the folded edge of your freshly washed fabric, including the small triangular notches along the side. You'll also need 2 40-inch strips of 1.5-inch wide fabric for the straps and extra pieces of 1.5-inch binding for the sides. Unfold your fabric pieces, iron them, and line them up on top of each other. It's important to be able to tell the inside and outside of the mask apart, so if you don't have 2 different fabrics to use here, place both sides right side down. Pin and stitch all the way around the perimeter, attaching the 2 layers together with a 1/4-inch seam allowance. Now it's time to iron the pleats. With the pointed edge away from you and right side down, fold up the lower majority of the fabric to create a horizontal fold that lines up with the top 2 notches. Press it with the iron, then fold the fabric back down at the next set of notches and iron it again. Repeat this pleat process 2 more times to create creases at all 6 sets of notches for 3 pleats. Pin the pleats in place and stitch them with a 1/4-inch seam allowance, basically over the same line you stitched just before. Next, to attach the binding at the sides, line up right sides together and stitch 1 more time over that same 1/4-inch seam. Then fold over the binding and iron it out to the side. Fold over and iron a 1/4-inch hem on the outer edge of the binding, then fold the whole thing in half to encapsulate the raw seam, and iron that 1 more time before top stitching. Now it's going to start getting 3D with darts. Fold the mask in half and mark the darts using the pattern, either with a marking chalk or pins. Stitch along the dart lines, then trim off the extra triangle of fabric. The last sewing step is to attach the top and bottom bindings, which are also the straps. Start at the middle, which you can find by folding the pieces in half, and pin the right sides together. Stitch a 1/4 inch seam like you did on the sides, then open up the binding and iron it flat, continuing that 1/4 inch fold down the length of the strap. Iron in another 1/4 inch fold along the remaining raw edge of the binding, then fold the whole thing in half and iron it again, encapsulating the raw edge. Top stitch both top and bottom bindings, starting at one end of the strap and continuing all the way across the mask and down the other strap. Trim all your threads and the sewing is complete. If you're making masks for somebody other than yourself, the last thing to do is wash the mask in really hot water and dry it, and then seal it up in a new plastic bag. Thanks for watching, and I wish you all good health.
Hey everybody, it's Becky, back with another Maker Tool review for you. Now, many pairs of wire strippers have come and gone in my life, but these wire strippers by Hakko have remained throughout. They've stayed sharp over years of frequent use, and this flared part of the handle really makes them a joy to hold and use. The rubber grips have like a powder mixed in with the rubber to give them a sturdy, really nice feeling grip, even if your hands are slippery or dirty. This pair cuts from 20 to 30 gauge wire, but they come in other ranges as well. They have a little metal tab that keeps them locked shut since they are spring-loaded, and the labels on the handles are actually laser etched, which I think is pretty fun. We also learned from them that this tool was made in Italy. I know the Hakko flush cutters usually get all the attention, and they're great, but it's worth considering that the strippers are more than just their sidekick. These are an essential part of my soldering setup. These wire strippers are just as at home working on electronics and robotics as they are on cars and motorcycles. They have a little grippy bit at the end, which is great for squishing down on hot heat shrink tubing or crimp beads. These wire strippers may look a lot like their cheapo counterparts, but they perform much better. The steel is harder and therefore stays sharper, the spring is sturdier, and the blades are kept in really tight alignment by the center pivot. In short, they're a pleasure to use, and you should know that pleasure if you get the chance. It's one of those things that if you're new to stripping wires and using a dull tool, you might just think you're bad at it. But starting out with a good tool can help build confidence in your skills. If you're interested in picking up a set of these wire strippers, I put a link in the description. Thank you so much for watching. Don't forget to subscribe to my channel here on YouTube and also my email newsletter, and leave a like and a comment down below. See you next time. Hey, it's Becky. Today I'll show you how to make this smart mirror that boosts your spirits with positive affirmations. The display is created with a few white alphanumeric displays wired up together and put behind a piece of see-through mirror glass inside a shadow box frame. Let's get started. This project is the topic of my recent tutorial article for Hackspace magazine, so be sure to check it out. You can get the PDF for free or subscribe to the print magazine. I put links to that and all the supplies you'll need for this project in the description below. The first step is to assemble the alphanumeric displays, which means soldering them to their I2C backpacks and also adding header pins. The way your microcontroller can tell them apart is by their address, which you can change by bridging these solder pads on the board. I have a sample test code for this project that scrolls text across multiple displays that you can use to verify the correct address and functionality of your displays. I strongly recommend testing your displays with a solderless breadboard before assembling them into your project. That way, if something goes wrong, you won't have to spend a bunch of time trying to test multiple variables at once. You can decide what microcontroller to use for this project. If you just want a static list of affirmations, you can use something simple and offline, like a trinket. I'm also working on a version using the Node MCU, since it has wireless, to make an internet-connected version. I've included circuit diagrams for both in the project tutorial. Next, you can lay out your circuit on a big perf board. I situated mine in the corner of my shadow box frame and then centered the row of 3 displays, but you can put them wherever you want. And it's not that hypercritical that you solder them in the correct order, since you can always change the address in the code later. Solder up the rest of the circuit and test to be sure it works as expected. To assemble the mirror, grab a piece of see-through mirror plastic or glass that is the same size to fit your shadow box frame, and cover one side of it in black tape. Cut out a rectangle that matches the size and position of the alphanumeric displays. This will make the mirror reflective everywhere except where the display shines through. If you want to hang your mirror on a wall, you'll also need to cut a notch in the frame to allow the USB cable to pass through while keeping the frame flush to the wall. What affirmations do you want to put on yours? I'd love to hear them in the comments below. Thank you so much for watching. Don't forget to subscribe to my YouTube channel with the bell to be notified of my future uploads. You could also subscribe to my email newsletter and find me on social media. If you want to support my work further and can do so without hardship, Patreon is the best place. See you next time.
Hey, it's Becky. Today I want to introduce you to a new board, the MeowMeow Mini. It's basically a capacitive touch keyboard, which makes it easy to turn almost anything into a controller for games and other apps. MeowMeow is created by my friends at Electronic Cats, a Mexican open source hardware company headquartered in Aguascalientes. Pondré subtítulos en español en este video. Also check out my friend Gus Merkel's MeowMeow Mini review video in Spanish. I'll put links to everything in the description below. MeowMeow Mini is a more compact, lower-cost version of their larger board, but has the same 10 capacitive sensors and USB connection. The cute PCB is in the creative shape of a kitty face, with all the components and labels on one side. The sensors are the whiskers. To get making with MeowMeow Mini, attach alligator clips to the through holes on the sturdy circuit board, and connect the other ends to whatever material you'd like to try. It's fun to experiment with what materials will work, since anything that's even slightly conductive is fair game. Connect the micro USB cable to your computer to use your new creation as a keyboard. Press the reset button to calibrate the sensors to the material you connected, and you're good to go. Here I am wandering around an online art gallery on New Art City. I'll put the link in the description. The 10 keys are WASD, up, down, left, right arrows, spacebar, and left mouse click. This kitten isn't reprogrammable like its big brother, but it's also only half the price, which makes it more accessible to educators and families doing STEAM projects with their kids. It's a great companion for Scratch as a controller for homemade games. MeowMeow is similar to Makey, which is a keyboard input board that uses resistive touch sensing. I think they're both awesome at helping kids and adults alike get a creative introduction to electronics that has a lasting impact. It's cool to see Electronic Cats create and sell hardware in Mexico, where they're able to reach local communities more directly and without expensive import taxes, while also reaching the wider North American and global markets. You can order a MeowMeow Mini right now on the Electronic Cats web store. The link is down below. Hey, it's Becky. Here's a quick tutorial for making a 3D printed adapter to connect your power tools to your shop vac if they're not naturally compatible. Let's get started. You'll need a set of digital calipers to measure your tools and a 3D printer. I'm using Tinkercad to design this part because it's free and extremely easy to use. For this example, I'll be using my own Ryobi planer and sander and my Festool shop vac hose, but these general instructions should work for any two tubes you have that are close to the same size as each other. You'll need to take 4 measurements: the outside diameter of the tool's dust outlet, the outside diameter of the hose terminal, and the length of each of those as well. Keep in mind that these openings are usually tapered to allow for a snug press fit, so the outside diameter measurement might not be the same along the length of the tube. I tried to take a measurement somewhere in between the smallest and the largest, and you'll inevitably need to do a bit of experimenting with the tolerance to get a good fit anyway. Once you have your measurements, it can be helpful to make a paper sketch. This can help you remember which measurement is which when you get into the 3D design environment and help you keep track of adjustments you make during prototyping. Opening up a new Tinkercad file, you'll create a cylinder to start. Match the height to the overall height of your coupler, then change the diameter to 2.2 millimeters greater than your largest port measurement. Next, create a cylindrical hole and set its dimensions to match that of your smaller tube. Increase the diameter by 0.2 millimeters to allow it to fit over the tube, that's your tolerance, and create another cylinder atop the first one with dimensions matching your larger tube plus 0.2 millimeters. You can use the work plane tool to rest the second cylinder exactly atop the first. Then select all 3 objects and use the Align tool to line them up on the X and Y axes. Finally, group the objects to cut out the hole. You should end up with a single tube whose opening changes size inside. All that's left to do is export the STL and slice it. I used Cura and set the print quality to low since this is a utilitarian tool and does not need to have a pristine surface finish. The first version took about 35 minutes to print on my Creality CR10S Pro. If at first the result doesn't fit or it's too flimsy, it's easy to go back into your Tinkercad design and make changes. Double-click on a grouped object to drill down into the group. I adjusted the thickness of the adapter walls by enlarging the main cylinder to make the whole thing a little more sturdy, and made a minor adjustment to one of the inner cylinders to get a better fit. The second and final version took about an hour and a half to print. It fits great and it feels pretty sturdy in PLA, although it would probably be more durable in something like nylon filament instead. If you want the step-by-step or the file for my Ryobi Festool adapter, head over to the link in the description. There's a similar video by Bob Claggett about making an angled adapter to connect his stationary tool to dust collection using Fusion 360, and I'll link his video in the description. Thanks so much for watching. If you liked this video, please give it a thumbs up and subscribe with the bell to be notified of my future uploads.
Hey, it's Becky. I recently put a ham radio antenna on my roof so I could get a better signal inside my apartment, which isn't on a high floor. Keep watching to see how it came together. The antenna I got is a VHF-UHF antenna that mounts on top of a pole. I put links to all the supplies I used in the description below. See, a few weekends ago, my friend David, my boyfriend Smokey, and I put up one of these on David's roof and on our own roof, and had 2 different mounting situations. At David's place, we used a mounting kit with metal straps and special brackets to hold the pole. The straps went around the chimney in 2 places. At first, we put it too low, and so we had to redo it up higher, so the antenna would clear the top of the chimney.
We put together the antenna by following the included instructions. Basically, we needed to screw in all the radials to the centerpiece, then tighten the nuts against the centerpiece to help prevent the radials from backing out when they wobble in the wind. The last step was to add the long radial that sticks off the top of the antenna, at which point the whole thing becomes difficult to set down anywhere. We ran our cable up through the pole and caught it at the top opening. We found this easiest to do with 2 people. The cable is stiff enough to stay straight in the tube when pushed up from below. We brought the antenna close to its mounting position atop the pole, then plugged in the cable and tightened the threaded collar. Threading the remaining cable slack back into the pole, we then seated the antenna atop the pole and tightened the set screws. Before running our giant cable all around the building, we tested the antenna to be sure everything was working as expected.
How do I sound now?
Yeah, probably about the same there. I don't know if any other stations are on over there. Yeah, probably about the same there.
We could hear and be heard by the Bronx repeater very clearly. At our place, there was an unused analog TV antenna pole that we planned to repurpose. To prep a previously used antenna pole, we had to remove what was still left of the old analog TV antenna. Some of its pieces broke off easily, while the final connection was so rusted that it needed to be cut free with an angle grinder. Although rusty around the connectors, the pole feels sturdy. The old antenna didn't fall down, and it's at least as heavy and wind-catching as the new one, but that's just a justification not to check with somebody who might tell me using this pole is a bad idea. Definitely get advice from somebody who knows what they're doing and who knows the local regulations where you live. We used a 75-foot cable to connect the antenna, then ran it around the roof railing and over the edge, following a bundle of existing cables down to our apartment window.
Smokey, did we get a long enough cable?
We did. Yeah, probably with 5 feet to spare, but not a lot. It's perfect size.
Thanks. KD2 SSU, Kilo Delta 2, Sierra Sierra Uniform, Becky in New York with my new rooftop antenna.
Then we heard someone new. I heard Kilo Delta 2, Sierra Sierra Uniform, Becky with a new antenna, new rooftop antenna. Welcome, Becky. We're here every night at 8 p.m.
The next very important step is to connect both the antenna pole and the signal cable to ground in case of a lightning strike. I ordered some bronze ground clamps online, but I got the wrong size. The clamps I ordered were too big for both the antenna pole and the electrical conduit I planned to attach to, so I flipped one of the pieces around to allow the clamp to fit a smaller diameter pipe. The downside here is it looks a bit silly, and if you over-tighten the screws, you could deform the pipe. The ground clamp has another opening designed for the ground wire to connect. I hooked up some 10-gauge copper wire to the clamp connected to the antenna pole and routed it to another clamp attached to an electrical conduit for a rooftop appliance, which is all grounded through the building's electric. But I'm not an electrician, so please assess your own situation with the help of a local expert to figure out the safest way to ground your antenna. On the other end of the signal wire, I used a grounding coupler to connect another piece of the 10-gauge wire to a ground clamp connected to that same electrical conduit just a couple floors lower. The coupler then connects to an adapter and wire to my Baofeng radio. As an ultra beginner without a lot of investment, it was perfectly acceptable to have to climb onto the roof to get any signal on my portable radio's antenna. But the benefit of this larger roof-mounted antenna is that now we can leave the radio on all the time and listen to it inside, which leads to more opportunistic connections and overall more time spent enjoying.
Thank you so much for watching. Don't forget to subscribe to my YouTube channel with the bell to be notified of my future uploads. You could also subscribe to my email newsletter and find me on social media. If you want to support my work further and can do so without hardship, Patreon is the best place. See you next time. Hey, it's Becky. Today I am reviewing Hunter Cat, a business card size circuit designed to root out magnetic card skimmers. Thieves use skimmers to collect your bank card information, most commonly at ATMs and gas stations. Dip the Hunter Cat into a magstripe payment device and it will tell you with some small LEDs whether it's safe to dip your bank card. I keep my Hunter Cat in the dash compartment on my scooter since I'm most likely to need it when I'm getting gas. But if I were traveling, I would carry it with me everywhere to identify safe ATMs. Hunter Cat is a collaboration between Mexican hardware company Electronic Cats and security researcher Salvador Mendoza. It works by detecting the number of magnetic stripe heads inside the reader. Too many and the Hunter Cat will tell you it's suspicious. The board goes to sleep after 15 seconds of inactivity, which saves the battery. To use the device again, press the reset button. The LEDs will flash to let you know it's ready to use. And then you can dip Hunter Cat into the magstripe reader and remove it quickly. Then look at which colored LED lit up. Green is good, yellow means it's suspicious, and red means you should definitely avoid dipping your bank card. It's pretty cool that this little ARM Cortex-M0 device can help protect against fraud and identity theft. You can order a Hunter Cat right now on the Electronic Cats web store. The link is down below. What new products should I try out next? Let me know in the comments below. Thank you so much for watching. Don't forget to subscribe with the bell to be notified of my future uploads, and follow me on Instagram and Twitter to see what I'm working on next. See you next time. Hey, it's Becky. Today's project is a pair of bedside shelves made from maple and epoxy resin. This wood has a bunch of beetle holes in it, some of which I filled using silver wire as an accent. Let's get started. These boards came from the same tree as my cross-cut cookie table. By now, the moisture content is super low, but at some point, these boards became a tasty snack for an unknown number of powder post beetles. The last time I visited in February, my dad helped me pick out a few boards and square up one of the edges. I took the boards home and eventually got around to finishing this project a few months later. During different times, I might seek to visit a shop with a thickness planer, but I settled for leveling the top surface of each shelf board with my handheld power planer. This is the project that really tipped the scales for me to make a 3D printed adapter to my dust collector, because the planer makes big chips that fill up the bag really fast, and plus the vacuum just does a much better job at capturing the chips so that I don't have to clean up wet sawdust on my roof. If you missed the project video about the dust port adapter, you can find the link in the description. Once the boards were flat on one side and the planer marks were sanded out, I took them inside and marked the rough positions of the shelves within the board so I know which holes I needed to deal with. Most folks might choose not to make a project out of this beetle board wood, but I wanted to embrace the holes instead. I happen to have some silver wire left over from some jewelry project that matches the average beetle hole size perfectly. I filled the holes by sticking the wire in and cutting it flush on the top of the board. I tried to scatter the bits around to create a sort of constellation effect, and I just kept going until I used up all the wire. Then I used some extra liquidy CA glue to drip around the silver bits so they would be sure to stay put during the later steps. Next, I set to filling the beetle holes with epoxy for the first round. I'm using art resin because it's got less noxious fumes than most epoxy resins, and it's also less yellowing over time. I followed the manufacturer's instructions and was sure to mix for the full 3 minutes. I used a glue syringe to get resin into each tiny beetle hole.
This process was oddly satisfying and didn't take as long as I thought it would. However, the wood sucks up a lot of resin at first, so I did go over the holes a few times to fill them in as much as possible. The work time on this resin is about 45 minutes, and I used a heat gun to pop bubbles along the way. I let that resin cure, and then came back with another pass to finish filling each hole so that it was at least flush with the surface, if not domed over. When all the holes were filled and cured, I cut the shelves to their final shapes before sanding. Then I filled the holes and cracks at each end of the shelf. I had a dust tent set up for my earlier steps, but it's really a lot more necessary for the final full coats of resin. I brushed on a thin coat to the underside first. This will prevent the wood from absorbing moisture from the air unevenly, which could warp the shelf over time. Once that was cured, I used some tape around the bottom edges to catch drips, and mixed up a fresh batch of resin to pour and spread across the top and sides. few hours later, I pulled off the drip tape and did a second coat of resin to level out any areas that had soaked up more than others.
The resin is hard to the touch after 24 hours and completely cured after 72. Since these shelves will each touch an interior corner, I used pocket holes along each edge to mount them. If they were flat on the wall with no corners, I'd probably use a bracket. I tried to find a stud for at least one of the holes and used anchors for the rest. These shelves are a welcome addition to our tiny Brooklyn bedroom, which really isn't big enough to host a proper nightstand or bedside table. These shelves are the perfect size to fit the essentials like your phone or glass of water, and I think they help elevate the otherwise mostly undecorated room. I'd love to hear your thoughts and resin project ideas in the comments below. Thanks so much for watching. Hey, it's Becky. Today's project helps make your day a little easier if you're a remote worker using Slack. I'll show you how to build it with an ESP8266 Wi-Fi board. Let's get started. Whether you're new to using Slack or you've just been using it a lot more lately, you'll understand the importance of setting your Slack status. It lets your colleagues know if you're available to chat, in a meeting, out sick, etc. Forget to set it when you leave your desk, and you may be interrupted by somebody who thinks you're available. I thought it would help me remember to have a physical device on my desk that can set my Slack status for me. This project is in collaboration with Brian Locke, who's an ESP whiz and author of many Arduino API libraries, including this new one for Slack. You might remember my YouTube subscriber counter, which was also written using one of Brian's libraries. The Arduino Slack API library gets you authenticated and allows the ESP8266 to control an app inside Slack. It's easy to configure your app and get your key, which you can plug into the sample Arduino sketch and get up and running in just a few minutes. From there, it's all about the physical interface and what statuses you program it to set for you. I chose to use a rotary switch to dial in my status from a bunch of choices around the circle. I modeled an enclosure using Tinkercad to mount the rotary switch and hold the circuit board inside. you so much for watching. Don't forget to subscribe to my YouTube channel with the bell to be notified of my future uploads, and check out Brian's channel as well. You could also subscribe to my email newsletter and find me on social media. If you want to support my work further and can do so without hardship, Patreon is the best place. Thank you to each and every one of my patrons. See you next time. Hey, it's Becky, here with another tool review for you. This time I want to talk about this helping hand tool from Hobby Creek. They're excellent for holding electronics boards and components for soldering, but I also use it for jewelry making sometimes, and I've heard that they're great for making fly fishing lures as well. The biggest advantages these have over the cheapo ones folks usually buy are the sturdy aluminum base and the long, flexible arms. The whole thing is very high quality, right down to the alligator clips. As a beginner, I remember being so frustrated with the default version of this tool. Over time, I learned hacks to improve it, but it never felt great to use a third-hand tool until I met this one. This product is brilliant on a few different levels. I love how the arms are reminiscent of, and may very well in fact be, the arms used to position a stream of circulating cutting lubricant like on a horizontal bandsaw. The milled base can support multiple arm configurations and also be bolted down if desired. I usually use 2 arms at a time, but the other ones come in handy for bigger and more complex projects. If you're interested in picking up one of these helping hands tools, I put a link in the description. Thanks so much for watching. Don't forget to subscribe to my channel with the bell to be notified of my future uploads, and subscribe to my email newsletter, and leave a like and comment down below. See you next time. Hey, it's Becky. Here is a comprehensive list of the gear I use to capture and edit my DIY projects, tutorials, and videos. My tool selection is optimized for my photography and videography practice and has been built up and refined over a long period of time. I maintain the advice that the best camera is the one you have access to, and you can get really far just using your phone these days. I'll put links to all my gear in the description below in case you want to shop. My primary camera is the Panasonic GH5S. I've also got a GH4 filming this right now, and I can swap lenses and batteries in between them. I'm a big fan of the mirrorless cameras for the lighter weight, since you know me, I don't have a lot of upper body strength. For my day-to-day use, there's not much difference between these two cameras, since I usually shoot in 4K, 24p, 8-bit color. But the GH5S does have a few more modes and capabilities for slow motion and low light shooting, so I made sure to get the fastest SD cards I could find to accommodate all of the camera's features. The flip-out screen is an absolute must for me, so I can mount the camera almost anywhere and still see the picture. I have an external monitor, but it's just a huge process to get it set up, and I like how quickly it is to get ready to shoot with the GH series. A port for plugging in a remote is an important feature to me, so that I can trigger the camera with my homemade foot pedal switch. I have 4 batteries between the two cameras, and I also have that battery compartment AC adapter for doing things like streaming or long time lapses. The microphone port is another must-have. For direct address, I capture audio using my Sennheiser ME2 wireless lavalier transmitter receiver pair. The receiver mounts easily on top of the camera. It has an XLR connector and an adapter to plug into the GH5S's mic port. The body pack transmitter has a monster rechargeable battery that lasts for like 12 hours. The receiver is smaller, but it comes with 2 batteries, each lasting at least 3 hours. I've never run out of battery during a long shoot day, but I guess if I were taking this stuff on the road, I might pick up another battery for the receiver. I also have a couple Rode camera top microphones for capturing native audio. They provide a lot better sound than the camera's internal mic, especially since I live in a place with a lot of background noise. I usually record from a script that's playing back on my Parrot teleprompter. This thing is so cool. It mounts to the end of the lens and turns your phone into a teleprompter. I sync the scripts to the app using Dropbox. For voiceovers, I use my Rode Procaster microphone with a shock mount on an arm attached to my desk. I boost the signal using a cloud lifter, and from there go into my USB audio device, which is by Focusrite. I've got a few LED panels called Light Mat. They're color temp adjustable and really lightweight and easy to use. I usually use my long skinny 2L as my primary light and fill in with these smaller ones. I hold them up with two Avenger C-stands that come with gobo arms. I always use a sandbag on the long leg, and I've got these cool pink and black shop bags from a local friend's lighting and grip company. I use another C-stand along with an extra gobo arm and a Cardellini clamp to get overhead shots with my camera. I used to use the Manfrotto Magic Arm, but my big change this year is upgrading this setup so that it allows me to capture more of the table while my arms can move freely back and forth. I still have a lot of love for the Magic Arm though, which makes it easy to mount a camera or monitor in tight spaces. As for more traditional tripods, I've got a few in a range of lightweight sizes. From my biggest is the Manfrotto Be-Free Live, which is the video head version of my smaller Manfrotto Be-Free. And then I've got a smaller Joby, as well as a tiny $10 Radio Shack one for using with my phone. I edit on my 2020 iMac. I use Final Cut Pro 10 to edit my videos, using a mixture of the onboard speakers and my old Sennheiser headphones. I've recently started to get more into streaming again, and for that I've got a Blackmagic Mini recorder to input my camera's HDMI signal and the Elgato HD60S for inputting from my Nintendo Switch. I store my cameras in a padded Pelican case. My favorite lenses are the Kit 12 to 35 millimeter zoom and the Olympus Macro 60 millimeters. I've also got the wide angle 8 to 18 zoom I'm filming on right now that I like quite a bit as well. That's it for my camera gear this year. I've got more tips and advice for documenting your DIY projects on my site. All the links to the things I mentioned are in the description below. Thanks so much for watching. Don't forget to subscribe to my YouTube channel with the bell to be notified of my future uploads. You can also subscribe to my email newsletter, find me on social media. If you want to support my work further and could do so without hardship, Patreon is the best place. Thanks so much to my patrons for directly supporting my studio upgrades over the years. See you next time. Hey, it's Becky. Today I'm going to show you how to create a simple yet customizable LED and battery circuit that's perfect for putting inside your next project. Let's get started. The most basic LED circuit can be made by sandwiching the legs around a coin cell battery. This is also a good way to identify the positive and negative legs of the LED, since it will only light up one way. That's because LEDs are diodes, which allow electricity to flow one way but not the other. The positive side of the battery should be touching the positive side of the LED, and it's usually longer so that you can tell the difference. Put a little tape on it and you can enjoy the glow of this circuit for about a day before it gradually dies out. This is a super hacky way to add LEDs to projects, but it works if you need it to work for only a short amount of time, like for costumes or props. If you want to create a durable circuit, it's time to bust out that soldering iron, or soldering iron, depending on where you're from. In addition to your LEDs, you'll also need some resistors, some wire, some heat shrink tubing, a 3-cell battery holder, either AAA or AA, and a switch if your battery holder doesn't have one already.
The specs of the LED, resistor, and battery pack must all work in concert to power the LED enough to light up, but not so much that it burns out. Here is a diagram of the basic circuit. Just as before, the LED positive side is connected to the battery's positive side, and likewise negative to negative. The current will flow from the battery through the resistor and LED and then back to the battery. The resistor and LED are connected in series, which means one after the other. In this way, the resistor limits the current flowing in the whole circuit, regardless of whether it comes before or after the LED in the circuit. And resistors aren't polarized like LEDs, so it doesn't matter which way around they go either. You can find LED resistor calculators online to help you figure out which resistor to use based on the specs of your LED and battery pack. But for these standard 10mm LEDs and this 4.5 volt battery pack, any resistor value from about 100 to 300 ohms will work fine. I'll go into more detail about the calculation at the end of the video. To create the physical circuit, strip a bit of the insulation off ends of the battery holder's wires as well as both ends of 2 more wires of your desired length. Twist and tin the ends of the wires by adding a bit of solder. Tin both legs of the LED all the way up near the plastic lens. Then fuse 1 wire to each of the LED legs by holding them together and reheating the solder so it flows between them. If you didn't add so much during tinning, you may need to add a bit more solder to get the best connection. If you use 2 different colors of wire, you can trim the legs of the LED shorter without forgetting which one is which. Add some heat shrink tubing to insulate the bits of exposed metal so they don't short out inside your project. If you only have 1 color of wire, you can label the wires with a piece of tape. Then add more heat shrink tubing to cover the next set of joints. Since they won't have open ends, we need to remember to add the heat shrink tubing first. Trim the resistor leads and solder it to either one of the LED wires. Then connect the battery pack wires, positive to positive and negative to negative. You'll need to add 1 more piece of heat shrink tubing to whichever battery wire ends up connecting to the other side of the resistor. In case you also need to add a switch, it goes between the battery's power wire and the LED positive side. Power up the circuit to confirm the LED lights up, and you're ready to put this in your next project.
Let's talk about adding more LEDs. It's easy. Just duplicate the LED and resistor circuit and wire it in parallel with the first. It means that both LED positives are connected directly to the battery's positive, and likewise, both LED's negative leads are connected to the negative battery lead. It's important that each LED have its own resistor to account for slight variations in the LEDs that prevent them from behaving exactly the same as one another. A lot of folks think that they can shortcut this with 1 resistor for everything, and it might work for a little while, but eventually that circuit's going to fail. This method of LEDs in parallel can work for upwards of 20 LEDs, or even more depending on your battery pack, but if it's your first time, I recommend sticking to 6 to 10 or fewer and keeping all the LEDs the same color. If you want to mix and match multiple colors in the same circuit, you're going to have to get more precise about which resistors you use, since they don't all have the same internal resistance. And the one that's easiest to flow through will get the most or all of the juice.
To assemble a circuit with multiple LEDs, you build the LED resistor assembly as before, but then join all the positive sides of the circuits together and all the negative sides together before connecting the battery pack. Your resistors can live at the base of the wires branching out or up next to the LED or anywhere in between, so long as you provide suitable insulation to prevent the wires from shorting out if they get tangled.
So why doesn't this LED coin cell battery circuit need a resistor? A coin cell battery is already the correct voltage, so that's taken care of, and then it happens to have enough internal resistance to prevent the LED from burning out. Coin cells contain lithium, though, and should be recycled with your e-waste, not thrown in the regular trash. What program are you using to make those diagrams? It's Tinkercad Circuits. It's great for this project because you can sketch out your circuit before you build it and even simulate it to make sure everything lights up. How do I calculate which resistor I'll need? Using Ohm's law. We'll solve for R, using what we know about the LED and the battery pack. On most sites that sell LEDs, you can find the data sheet and look up its forward voltage and its forward current. The battery pack has its cells wired in series, which in this case adds up each 1.5 volt cell together for a total of 4.5 volts. You can plug these values into one of the many online resistor calculators or do it out by hand. If you don't have the exact resistor, it's okay usually to go up to the next common value. If your LEDs are all the same color, you can compromise even further in the upwards direction, which will just dim the LEDs a little bit. If you have more questions, be sure to leave them in the comments below. I'd also love to find out what you're adding your LEDs to. Thanks so much for watching. Check out my cable splicing video for more soldering tips, and subscribe with the bell to be notified of my future uploads. You can also subscribe to my email newsletter and find me on social media. See you next time.
Today's project is a very 80s upgrade to a very 80s scooter. I'm putting an LED strip in the grille of my boyfriend's Honda Elite to create a Larson scanner animation effect while teaching him how to solder.
Where you go from there is entirely up to you.
And always wear your helmet.
Honda scooters. They're everything but ordinary.
For this project, I used a piece of WS2812 LED strip, also known as NeoPixels. I chose the densest variety to pack as many LEDs in as possible for a nice smooth animation effect. I used a Trinket microcontroller and Phil B's excellent Larson scanner code. I'll put a link to his tutorial in the description, as well as my full write-up for this project. The board is powered directly from the scooter's 12-volt power, so we attach wires to the power and ground pads on the back of the board. Since the Pixels can't handle 12 volts, they're being powered by the Trinket's voltage regulator, which isn't generally a good idea. But since there are so few LEDs lit up at once in this animation, we can sneak in under the regulator's max current output. Enjoy the rest of the build. Thanks so much for watching. Don't forget to subscribe to my YouTube channel with the bell to be notified of my future uploads. You could also subscribe to my email newsletter and find me on social media. If you want to support my work further and can do so without hardship, I would so appreciate your membership on Patreon or here through YouTube channel memberships. See you next time.
I'm saying goodbye to 2020 by burning a 2020 candle made with a 3D printed mold. I embedded a handmade ornament inside, made from sheet metal. The little dumpster fire is revealed as the candle burns. I was inspired by Pyro Pet candles, which have a little sheet metal skeleton inside. Keep watching to find out how I made it. I had the idea that I should be able to 3D print a mold for liquid wax to make this candle. See, the melting temperature of the wax is way lower than that of the PLA filament. I had made soy wax candles in the past, so I pulled out my candle making supplies and did some research online.
I found out soy wax is much too soft to use for casting. It won't pick up fine details or hold its shape after demolding. My research suggested beeswax or paraffin are more suited to molding into freestanding pillar candles, but that beeswax is notoriously sticky, making it difficult to remove from molds, so I chose to start my experiments with paraffin wax. You can find a complete list of supplies for this project at the link in the description. I modeled the mold using Tinkercad. I started with an SVG file I made in Illustrator for the basic 2020 shape. I extruded this shape for the basic candle design and added a block to fill in all the voids and make it so the numbers are only sticking out a little bit from the rest of the candle. Then I turned the whole candle design into a hole instead of a solid and grouped it with a larger shape that becomes the mold itself. I split it in half and added some channels and ridges for alignment so that the mold could be removed from the candle. I didn't add a bottom to the mold since I planned on using a different material for the floor. I printed the parts in orange PLA filament on my Creality CR10S Pro 3D printer. It took about 10 hours to print using 20% infill. Before I could even think about adding the metal bit inside, I needed to figure out if this technique would work in the first place. I had concerns that maybe the PLA would distort, that the mold might leak, and that the candle might just not come out of the mold cleanly. To prepare the mold, I first glued one side of it to a flat piece of plastic I got from some recycled packaging. You could use what you have around, maybe like a plastic clipboard or a piece of melamine. Then I secured the wicks to the floor, also with hot glue, followed by the other half of the mold. I added hot glue on the outside of all the seams. When that was set up, I tightened up the wicks and secured them in place at the top of the mold with these special wick holders. The wax melts over a double boiler. At first, I used a candy thermometer for taking my wax's temperature, but it's too slow for candle making. Later, I switched to using my multimeter's infrared thermometer, and you could also use an instant read meat thermometer. To mix in the powder dye, I first mixed it with a little rubbing alcohol, then poured it into the melted wax and stirred until well combined. The alcohol actually just evaporates off. I poured the wax when it was still very hot, between 160 and 175 degrees Fahrenheit. Lots of little bubbles escaped during the first few minutes after pouring. The candle took hours to cool and formed a decent sinkhole in the middle when it did, because it shrinks. I just heated up the leftover wax in the pouring pitcher and topped off the candle a few times over the course of the next several hours.
This project is part of a collab with my friends 8 Bits and a Byte, Make It and Fake It, Hannah Makes, Ian Sharness, and Natasha from Techno Chic. Watch all the ways we say goodbye to 2020 at the playlist in the description, including our dramatic supercut.
The next day, I removed the hot glue by applying some rubbing alcohol. It releases the bond, so it comes off like magic. I carefully wedged my awl in the alignment grooves to separate the two halves, and then delicately pulled each half off the candle. To my delight, it came out almost perfect. I added info about some less successful tests in the write-up for this project, which you can find at the link in the description. Testing success meant the metal bit inside got the green light. I created a dumpster fire ornament design in Illustrator, then printed it out and pasted it to a piece of 18-gauge sheet brass. It's a Christmas tradition to add a new ornament to the collection every year, so the flame-kissed dumpster fire will always remind us of what a year it was. I cut along the template using a jeweler's saw. I didn't bother too much with sanding or filing on this piece, but if you're interested in learning more about this type of small metalworking, you can read my tutorial on the subject. I repeated the process of prepping the mold and pouring the candle, adding the brass piece right before the wicks. I weighed my test candle to see how much wax was needed, and it came in at a whopping 750 grams. That's over 1.5 pounds of wax. To light the candle, I created an automatable fire starting device using a model rocket starter and some flash paper. The idea was that our collaborative projects are all triggered by the same text message. But without enough continuous fuel to ignite the wicks, this trick was all show. I'll admit I had to fuss with it a little bit during this time lapse to get it to burn evenly. The size and placement of the wicks, as well as the thermal properties of the brass, are all factors in how it melted down. The ornament, now freshly blackened by the flames, joined the other Christmas decorations.
Thanks so much for watching. Don't forget to subscribe to my YouTube channel with the bell to be notified of my future uploads. I want to thank you extra if you're subscribed here or to my email newsletter, or if you follow me on Instagram or Twitter. Your support is what keeps the projects coming. Special thanks to my patrons on Patreon for so directly supporting my work. Happy New Year! See you next time.